Hello. Okay, so today we're going to talk about what it actually means to be 95% confident. For you guys, we know it already from the empirical rule, as we would expect 95% of our data to fall within 2 standard deviations of the mean. But when we're talking about creating a confidence interval, it's similar. We're now trying to say that we are confident that the population's proportion will actually fall in this zone that we have calculated, which is called our interval. So today we're not going to actually calculate them. We'll calculate the interval starting tomorrow. Yesterday we introduced vocabulary. Today we're going to look at the intervals and see how it works, and then we'll get set up for calculations. First things first, we are going to go to our confidence intervals applet and set our population proportion to 0.5. That's a piece of information that your problem would have to tell you and present to you. We're not usually going to know the information about the population. Hence, we're creating statistics to represent what we think is the best estimate for our population. So be sure you set yours to a sample size of 75, and then our instructions are going to be to take a symbol random sample, display our resulting confidence interval. It'll be on your screen. We'll put it onto our paper. So let's just go make sure you're set up and that you can take a single sample. So here I have mine set to 0.5 for my proportion, 95 for the level, sample size of 75. Be sure you change that sample size. And I am going to choose the button to find my first sample. You could see it up at the top of the screen. It gave me the confidence interval in terms of the point estimate, which is 0.493, plus or minus the margin of error. Those are your words from yesterday. The margin of error is 0.11. So the center is a little bit left of 0.5, which is the population's proportion, and we can draw it here. So we've got our center a little bit left of 0.5, and then it spread out 0.11 on each side. So it went to about here on that side and there on that side. Okay, it should be the same on both ends. And our continuing job is to answer the question, did our first interval capture the true proportion? Well, remember, your true proportion is in green. So is it within that blue interval? Hopefully you're thinking yes. The green line does fall within our blue interval. Okay, so we're going to repeat this 10 times. I'm not going to talk through it. I'm just going to go run 10 of them, draw them on my piece of paper. You can run your own or you could follow along with mine. It's up to you. And then we'll meet up when we finish. So let's go grab 10 more of these suckers. Notice mine's not perfect. I'm just kind of extending the wing things on each side. The key is just making sure whether or not you can tell it crosses the green line. Okay, my last one. Okay, so there's my 10 times, how many of my intervals actually captured the true proportion. And we're going to want to think of it as a percent, but that's okay. Right now, we'll just talk about it as a number. So for mine, 10 out of 10 of mine captured the true proportion. I don't know what you got for yours, but my guess is that you probably either got 9 or 10. If you didn't, that's okay. It's everything's statistically possible. It's just less probable. So reset, take a total of 100 confidence intervals. So sample 25 4 times. And how many out of the 100 captured the true proportion? Is it surprising and why? Okay, here we go. Let's reset. We are now going to sample 25 4 times so that we get 100 of them. So 1, 2, 3, 4. If you look on the left side, it tells you the percent that actually captured the true proportion. So it's convenient. You don't have to go count them all up. You can if you really wanted to. But knowing that 99 out of the 100 captured the true proportion means that we only had one that didn't. So over here, I'm going to say that about 99% captured the true proportion. Is it surprising? For me, no, but I would have expected 95. I'm guessing that some of you out there that are doing it on your own probably got 95%. The reason? Because of the confidence level we chose. We chose a confidence level of 95%. And so the more and more samples that we draw using that confidence level, the more and more intervals are going to capture the population's proportion, and it should match. So let's work on how we can state what's happening and what we're seeing happen in words. Okay, watch your confidence intervals as you drag the confidence level from 95% to 99%. Don't reset. What happens to the intervals when the confidence level is increased? Why does this make sense? Okay, let's see if we can drag our confidence level to 99. So here I've dragged mine to 99. Sorry, I had to click out for a minute because my mouse was not working. What you notice is that the percentage that it hit, it's still 99%. That's because our last one, we expected to see 95, even though we saw 99% happen. So on this one, I'm not really surprised, but we can say at least that as we increase the confidence level, and I'm going to abbreviate it CL, the interval gets wider. And that means we will capture the true proportion more often. So let's look back at this. If you think about it, look at all those intervals. If you didn't see it happen, put it back to 95% confidence. And then look at the intervals again. They all got wider. You could tell the number. It doesn't show you the numbers on this one, but go play back and forth with that. You'll see that the width of those little whisker looking things got wider. Reset it, look at it at 80%, and then tell me what you notice. So hopefully, I'm going to let you do that one. As you reset it to an 80% confidence level, hopefully you noticed that about 80% of the intervals captured the true proportion. Interpreting. Okay, and we know what that means. We're going to get our fill in the blank response that we're going to use. This one I'm not going to do as the fill in the blank. I'm just going to write an interpretation for the 80%, and then we'll do your fill in the blank for our big idea. So remember, interpreting is your formal wording at the end when you kind of summarize what you found. If we make a lot of those confidence intervals, so 80% confidence intervals that were size 75, we would expect about 80% of them to capture the true proportion. And remember, the true just means the population's proportion. Okay, now we will see what happens when we adjust the sample size. Change the sample size to 20 and sample for one interval. Then change it to 250, sample for one interval. What happens to the interval when the sample size is increased? I'm going to let you guys do that now that I've showed you how to play with the applet. Go change the sample sizes and peek at it, and then pause if you need to, come back, and let's talk about what you noticed. Okay, so hopefully you noticed that as you increased the sample size, the interval got narrower. Think about what happens in your formulas that you've learned. The sample size is part of the standard deviation, and it's in the denominator of it. So when you increase the denominator of your fraction, that value gets smaller, and standard deviation is widths. And so hopefully you're making some connections here about your language and what makes sense to you. As the sample size increases, as the sample size increases, the standard deviation or the variability decreases. Okay, so that's kind of the gist of today's lesson. We're going to use this learning experience to do the check for understanding problem and to formalize some of these big ideas on the next page. So let's scroll to the next page and talk about what we learned. At the top of your check for understanding, you should find your big idea. And first things first, let's discuss what affects, well, let's interpret our confidence level. I'll give you that formal wording. I think that came up first. So whenever you need to interpret a confidence level, notice it's not the confidence interval, it's just the percent. What does that percent mean in statistics? Here's some good formal wording with fill in the blanks, just like we have in the past for interpretation, so you can use it for any problem that you come across. If we create many blank percent confidence intervals of size blank, we expect about blank percent, should be the same percent, to capture the true, and then you've got your blank. And it's either going to be proportion, which is P, or mean, which is mu. Be sure that those two symbols are your population symbols. Okay, so there's your interpretation. Let's talk about what happened. How did changing the confidence level affect what our intervals were. So first, one thing that we did was when we increased the confidence level, and I'm going to put this in more of a notation format than in vocabulary words. If we increased the confidence level, then we saw that it increased the margin of error. So I'm using some of the symbols and ideas that we did yesterday. That was from number 4, by the way. We saw this happen in number 4 from our problems. If we increased the sample size, I'm going to label it in, then what we saw happen was that it decreased the standard deviation, which also decreased our margin of error. And we saw that happen in number 6 on our worksheet. So those are just some things to remember. These are great multiple choice problems and questions. For you to study. We'll come back to those eventually when we talk more about how to change sample sizes. Okay, let's see here. Check for understanding. Ready to do a problem? This is our last thing, and then you guys are on your own to practice it on your homework tonight. Let's read the problem together because I need to read it, and then we'll walk through it. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students at her school. Okay, so first of all, annotate what you read. Let's go look at everything. We have a random sample. Always think of it as one of our checks. There's 25 students in our sample. So N is 25. We are 90% confident. There's your confidence level. And they gave us the values for the interval. So our confidence interval is going to be 3.14 up to 3.52. Now I want to point out to you that in this wording, there was something really important that got brought up. It captures the mean GPA for all students at her school. That is your population. It should always be found in your problem. So it's not a guessing game. Go back, reread. It's going to take some careful reading on these problems to make sure that you're understanding everything that they're giving you. Also, I want to point out that notice it said the word mean. Well, we just did our example with proportion problems. So if you need to pause this and take a break and go look at the other lesson that I posted for you, it walks you through exactly the same thing we did with proportions, but it's a lesson on means. And so if you wanted to practice it for a minute and look at that applet and play with it, you'll learn the same stuff just with our symbol for mu instead. So feel free to pause it if you want to. I'm going to continue working through this problem so that way you've seen our example with proportions and you've seen this check for understanding with means. Okay, let's interpret that confidence level. Be careful on your wording. Notice here it said confidence level, not interval. You have two interpretations right now. We have learned how to interpret the confidence interval and today the confidence level. So just be sure that you are paying attention to what you're being asked. Okay. If we make or create many 90% confidence intervals of size 25, about 90% of the intervals will capture the true mean GPA. Okay, done. Explain what would happen to the length of the interval if the confidence level were increased to 99%. So here is where you don't need to go back through details. You don't need to use the applet and change it. Here's where you just use what we learned up in those big ideas and say that an increase in the confidence level means that it will widen the margin of error. It will increase it. So that means it widens the interval. And again, that's what we looked at in the applet. So if you need to go back and play with the applet with the means problems, because that's the one we didn't use, then go see what happens. Set this up with 90%, watch it go to 99%, see each of those intervals widen as you do it. Okay, part C, how would a 90% confidence interval based on a sample size of 200 compare to the original 90% interval? So they didn't change our confidence level. That's important for you to realize that stayed the same, which means the only change that happened is this sample size here of 200. So basically, if we increase the sample size, we had a big idea on this. Go look up above if you need to. If we increase the sample size, that means we are decreasing the standard deviation and in turn decreasing our margin of error, which means to answer the question about comparing the intervals, our new interval would be narrower. Oops, sorry, wrong word. Okay, so you can write these descriptions in complete sentences. You can write them with symbols and then an explanation like I did. Totally your choice. Doesn't matter as long as you're clear. Please be sure you put a reason. Don't just throw out there that the interval widens. Tell me why. Part D, describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. So as we know, bias is not about error. Error is separate, and it does not cause bias. Bias is caused from how we've set our situation up. So let's look into our situation a little bit deeper and decide why this might be biased. If you're trying to think of something, the first thought for me is that students might not tell the truth about their GPA because this is a student study. And so if she's probably just asking them, she probably didn't go look it up on the internet or in the grade book. My guess is that, as you guys know, if you're embarrassed about it or if maybe the GPA is too low, that might be a source of bias. Notice it said source. So the students might not tell the truth. Where the bias comes from. It didn't ask for the type of bias or the name of the bias, and it actually didn't even ask you to discuss how it affects the parameter. Now you could say that the GPAs are most likely overestimated. They're higher than what we'd expect them to be because most likely students would inflate their GPA and lie and pretend it's better than it is. But it didn't ask for that. Don't write more than is needed just in case you accidentally make a mistake. Okay, so that takes us to the end of our lesson. You guys can now flip over and work on your Khan Academy and your book work for this section. Thank you for joining me, and I will see you on Google Meet if you have a question. Bye.